Hey there, welcome back. So this section, as well as the next section, they're really one massive section, but I split it in half just so I don't end up with this one behemoth section. But both of them have to do with algorithms and problem-solving patterns or strategies, game plans, approaches, whatever you want to call it. Basically, you're faced with a tough challenge, some code or a problem you have to solve, and you don't know how to do it right off the bat. What are the steps you can take to make it solvable? And it really falls into two categories. This first section is more about the basic approach to solving a problem you don't know how to solve. Steps you can take, things you can do to make it easier. And then the second section that comes after this is about specific blueprints or archetypes, little strategies you can keep in your back pocket that help solve a lot of problems. So it's more code specific in the next section, but both are equally important. But first, objectives really quickly. We're going to start by defining what an algorithm is in like 10 seconds. Devise a plan to solve algorithms, and then compare and contrast problem-solving patterns, including things like frequency counters, two-pointer problems, and divide and conquer. So that's coming up in the next section. Like I said, this section is really more focused on devising a plan, sort of an approach to solving problems. And then afterwards, we'll dive into specific named patterns. Okay, quickly, what is an algorithm? Well, in today's world, it's like the trendiest of the trendy buzzwords. I was watching an ad the other day I was on Instagram, and there was an electric toothbrush, and they were advertising, this finely tuned algorithm for the vibrations in the toothbrush. It's a word that you can't escape. Really, it just means a process or set of steps to accomplish a certain task, a rather underwhelming definition. But that's all that it is. So when we say algorithm, we could be talking about, a set of mathematical steps that we need to do to solve a problem. We could be talking about Facebook's algorithm that, suggests certain ads to you, or Google's algorithm when you search for something, where it's a matter of, 50 developers working together. It's probably vastly underestimating it. Maybe 100 developers who are working on search result algorithms over, 10 plus years. So it really runs the gamut. But at its core, it's just a set of steps to accomplish a task. So that could be something simple like, calculate the first 100 prime numbers. There's many ways of doing that. Or it could be something like, Instagram's algorithm that used to just show you results in chronological order, and then they decided to change it, and now you miss a million posts about your friends. Anyway, why do you need to know this? Well, hopefully this is sort of clear already. Almost everything that you do in programming involves some sort of algorithm. Whether it's super basic things that you're doing or you're building a complex application, you have to make these decisions. You have to come up with a way of solving problems. So this stuff is super important. But I do want to sort of constrict our definition of algorithm for now. We're not going to learn how to solve Instagram's timeline algorithm. We're focusing on really a much narrower category, and that is things that come up in interviews. So this is probably why a lot of you are taking this course. Yes, this stuff is good to know. Especially this section applies to a lot of programming, pretty much everything, but it also really applies to interview settings. Being able to, sit in an office somewhere you've never been and answer tough questions or solve a problem you've never seen before. So just to reiterate, this stuff comes up all the time in interviews. Oh boy, how many of these did I do? Okay, interviews. There we go. So how do you get better at this stuff? A lot of people think this is just inherently, people are good or bad at it. And I've seen that a lot when I'm teaching. Some people are just naturally better at solving problems, I would say, or their brain works right out of the box at solving problems. But that doesn't mean that it's hopeless for people who struggle. I've seen it many, many times in my classes during our interview weeks towards the end, where we're doing computer science and sort of what this course is based off of. Some people pick it up much faster. Other people have to work towards it, just like anything in life, honestly. But I've seen many people turn it around and struggle during our first mock interview and have a panic attack basically in the middle of our conference room. And then a week or two later, brand new problem they've never seen before, equally as difficult, they're able to sit there calmly and solve it using some of the steps I lay out here. So how do you improve? There's two things. I've already mentioned this. First, devise a plan for solving problems. So this is more of a non-technical, it still is technical, but it's more about how do you approach a problem, strategies for breaking it down. There's a couple steps that I recommend. And then afterwards, master common problem solving patterns. So a lot of algorithms, especially in interviews, a lot of these problems that come up can be broken into sort of different categories. And if you can identify some of those categories, there are some steps you can take in your code, some recipes you can keep that you can pull out and that will help you solve the algorithm or the challenge. We're starting off with this first one, problem solving strategies. So this section is focused on a simple, foolproof, magical, miraculous, fail-safe approach to solving every problem ever, which can be yours for only 2 payments of $999.99. Call now. No, not really. This is not at all what this section is about. This is just laying down a set of steps that can help you. But of course, it's not going to solve the problem for you. It's not foolproof. But I've seen many people, like I've already mentioned, turn their problem-solving approaches around. Many people who have gone from feeling really apprehensive about solving new problems and lock up in the middle of an interview setting, and giving them sort of a game plan, a set of steps that you can keep in your mind is a concrete thing to refer back to, step by step, what you should do. And I've seen it help a lot of people. So it's not miraculous, it's not magical or foolproof, but still is pretty helpful. So what are those steps? Well, first, understand the problem. So each of these bullet points will get its own video. Understand the problem, explore concrete examples, break it down, solve/simplify the problem, and then look back and refactor. So these are the different videos we're going to have in this section. Each of these points, there's a lot more behind it, and each one is part of this plan, this game plan, this recipe for solving a challenge or a problem. So that's where we're going here. And then the next section is on more concrete archetypes for algorithms, but we're starting here. All right, so problem solving, hopefully you know why this is important. Don't make me go back to this slide. It's too many button presses. Interviews, yeah, great stuff. Okay, let's get started in the next video. Welcome back. So as I mentioned in the last video, one of the biggest challenges for new developers, new programmers, has to do with solving problems. So I think for most people, it's easy enough to learn the syntax. It might take a little bit of time, but you learn the syntax and you're done. You can copy, other people's code or remake an application following step-by-step instructions. But the hardest thing has to do with solving new problems and new challenges. And you do get better with time, regardless of the technologies you use, the language that you're working in. It's really important to have a strong problem-solving skill set. And a lot of it will come naturally with time. But it's worth being deliberate. It's worth having a game plan to follow, step-by-step guide. It's not going to solve your problems for you, but it helps you sit and think about and break problems down, and it helps solutions come about more naturally. So I mentioned these 5 steps that we're going to talk about. This video is going to start with understand the problem. Before I go any further, I should mention that many of these strategies are adapted from a really good book on problem solving in general. It's sort of more slanted towards mathematics, but it's by this guy named George Polya. The book is called How to Solve It. It's a great resource, and it's where a lot of these tips come from. Okay, so we're starting with understanding the problem. So imagine you're sitting in a room. It could be a beautiful room, or it could be like a prison cell made of cinder block, and there's an interviewer ahead of you, and he or she asks you a question, and you don't know how to solve it. And it doesn't come to you right off the bat. It's not one of the practice problems you memorized over the weekend studying before. So the first couple of things I would do have to do with understanding the problem. And it can be tempting just to dive right in and start solving something, in particular when you're under some sort of time constraint, like in an interview. So most people just their heart starts racing, they just want to get started immediately. And this is true in programming in particular. You can make progress even if you don't get it right. You can just type a bunch of code pretty quickly and feel like you're making progress in a short amount of time. But before you start typing or whiteboarding or whatever you're doing, I think it's really important to take a step back and just make sure you understand the task ahead of you. And that sounds silly, it sounds trivial, but there are some very deliberate questions that you can ask, a thorough investigation of the problem or of the question, and it can really help clarify things, and sometimes will give you an aha moment, although not always. So here are some of the questions that I recommend you ask yourself Or if you're in an interview setting, ask the interviewer. But also if you're working on your own challenge, you're trying to build something out and you're not sure how to approach it, ask yourself these questions. So can you restate the problem in your own words? This is always the first thing I ask my students to do in an interview setting. You get a new question, just make sure you can restate it back, not word for word. Don't just copy what the interviewer said, but change it a bit in your own words to make sure that you actually understand what the question is. What are the inputs that go into the problem? So this is a really important one. What about the outputs? So what are the outputs that should come from the solution to the problem? What should the output look like? And we're going to dive into an example in just a moment. So what are the inputs? What will the inputs look like? What are the outputs? What should come from my solution? What should be returned from my function? Can the outputs be determined from the inputs? Meaning, do you have enough information to solve the problem? You have the inputs. Can you get the outputs that are expected just using that information? And sometimes you need to wait a bit until you can figure that one out. How should I label the important pieces of data that are part of the problem? So this would be, what are the things that really matter in this problem? What should you call them? What's the terminology that you should use? So it might seem like a lot, and it is, but if we walk through an actual example, we're going to do a really simple example, which is write a function which takes two numbers and returns their sum. So imagine that someone asks you this in an interview setting. Let's explore sort of understanding the problem through this lens. So let's walk through some of these steps. Write a function which takes two numbers and returns their sum. Can I restate the problem in my own words? All right, well, this one's nice and simple. We could just say something like write a function that adds two numbers or implement addition, something like that. Okay, easy enough. What are the inputs that go into the problem? Well, this might seem like an open and shut case, just add two numbers, so we need two numbers, right? But if you start to really think about it, it really depends. I mean, are we talking about integer numbers? Are we talking about floating points exclusively? It depends on the language that we're working in, of course. How large are these numbers going to be? Because in some languages, most that I've worked in, there's an upper bound for the size of numbers. And if you're trying to add really, really large numbers, it doesn't work well. For example, if we tried to do this here, it's a really large number plus, there you can see it's a plus sign, another really large number. Totally valid mathematical operation. But in JavaScript, what do we get? Infinity. It just gives up and gives us infinity. So in other languages, you might be able to represent this better as a string. Each one of these numbers, I won't actually do it for both, but an implement addition using the strings. So it actually really does matter, right? It's not a trivial question. It's silly to just add two numbers together. We already have addition. Why do that? But if we just think about it, we already start to figure out that there are some important distinctions between these inputs. And if we are trying to add these really, really large numbers, suddenly the problem becomes a lot harder because in JavaScript, we can't do that just with plain old numbers. Another thing is, are we only working with two inputs? Is it always two? What happens if someone leaves an input off? Or what if someone wants to add 4 or 10 numbers? Like that's totally valid to add 10 numbers together mathematically. Is our function only going to work with two numbers? And the same applies to the third question, which is outputs. What should the output look like? This is simpler in this case. We still would have the question of, should it be an integer? Should it be a float? Depending on, if you pass in two floats, do we want a float back? If you pass in an integer and a float, are you even allowed to pass in a float? Or what about a string, returning a string if we're doing this massive addition? So it's sort of the same question. Well, it's not the same question, but it's a lot of the same issues. Next up, can the outputs be determined from the inputs? Basically, do we have enough information to do the problem? And in most cases, the answer would be yes. But if you think about it, what happens if someone only passes one number in, as we already discussed? We don't have enough information to do addition at that point. So do we add 0? Do we return like undefined or null or something? What do we do? And that depends. You ask your interviewer that, or in most interview settings, they might just tell you to ignore that for now. But also in most interview settings, they probably wouldn't ask you to write a function that takes two numbers and returns their sum. And lastly, how should I label the important pieces of data that are part of the problem? So I like to put this in here because it's important to start thinking about this. What matters? So we have the inputs and we have the outputs, and that's pretty much all we need. So maybe, we'll name our function add, and then we'll have num1 and num2 as the arguments, and then sum is our result that we return. So this is simple, But once you start getting into more complicated problems, thinking about this step by step really can make a difference. And I'll show you some examples where it helps. But first, let's move on from understanding the problem to exploring concrete examples. So this was only the first step, but there were still multiple questions that we can ask ourselves or ask our interviewer about the problem. All right, next up, exploring examples. Hey, welcome back. This is part 2 of the simple 5-step program to changing your life and realizing your dreams, as long as your dreams have to do with solving problems. That doesn't include family problems, medical problems, personal problems, problems with your pets, peeing on your brand new furniture. It only applies to code programming challenges, unfortunately. And I've been viewing this through the lens of interviews, but it really does apply to any sort of code challenge that you're trying to solve on your own. Okay, so step 1 was understand the problem. Step 2, after you've done that, explore concrete examples. So we're back in our cinder block cell. Our interviewer has asked us a question. We have a moment of panic. We start by understanding the question, trying to figure out and make sure we understand the inputs, the outputs, all that stuff we talked about. The very next thing that I do, and I recommend all my students do when we talk about interview prep, is come up with concrete examples. This is tied very closely to understanding the problem. So coming up with examples can help you, can help you understand the problem better. Examples also provide sanity checks so that your eventual solution, if once you have a solution, you can tell if it works how it should, because you'll know at that point, you already have the examples. You know the inputs and the outputs that you should get. So if you have those examples, you can check your work. But also you can learn more information by doing these examples. And this applies on a larger scale. Things like user stories. These are examples. If you're not familiar with user stories, it doesn't matter that much, but if you're working on a product, like at Instagram, when they're solving a challenge, they're building a new feature, you bet that they start with user stories at some point they do, which is basically given an input, what is our output? Except the input is, a user action. What should happen after that? Or unit tests on a smaller scale, but still, bigger context than an interview. Unit tests are used all the time to help lay out, how something should work for a smaller feature. Okay, so here are the steps that I take around exploring concrete examples. So you're faced with a problem. The first thing that I do is start with simple examples. And I literally, if I'm in an interview or if my students are in a mock interview, I tell them, all right, you restated the problem already, you understand it. Now write down 2 or 3 simple examples with an input and then the output. And I really actually like to write this down so I have it and I can look back at it. So simple examples, the ones that should make the easiest use cases. Then progress to more complex examples. And then what about edge cases? Explore examples with empty inputs. That will often give you some insight into how the problem should work, especially in an interview setting. Explore examples with invalid inputs. So this is more useful, I'd say, in the real world. What happens if a user enters something that is invalid, right? We have to think about this all the time. So let's explore this with a concrete problem. So our interviewer asks, write a function which takes in a string and returns counts of each character in the string. So relatively straightforward problem, but there are many questions, many examples that we could try out and use to learn about the problem. Okay, so someone just asked me to solve this problem. I'm in an interview. I want to check that I understand it first, so I try and restate the problem, do all the stuff from the last video. Then I like to come up with a couple simple examples to make sure I understand it. So let's say our function is called char count. I would literally write this out. So char count of like A with 4 A's. Well, that should return something that looks like this, I would assume. Returns counts of each character in the string. This is, we've already gathered that it needs to return an object, let's say, instead of an array or some other data structure. So I would try this, and that's how it should work, I guess. Char count of hello should return something like this. But already there's a question that I have, which is, should it just return the letters that are in there? What about the letters that aren't there? Do we want to include, B0 and C0? Because if we did that, it might make our code a lot easier. If every letter was already in there set to 0, then it makes it simpler as we go. We don't have to add in A or B if it's already in there. We just have to increment it. So that's a question that I would try and clarify. So the next step was progress to more complex examples. So what about something like this? If somebody did something like my phone number is blah, 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 and that's not a valid phone number as far as I know. So if this was an input, what would we expect to return? Do we want to account for spaces? That's an important one. What about other characters, dollar signs, underscores, numbers? That's a big one. Are we going to put numbers in there? And an even more important one that definitely would come up, what about this? Hello, hi. Are there, do we store an uppercase H and a lowercase h? Do we ignore casing? How should this work? Should our object have H uppercase 1, H lowercase 1, or just H 2? So these are more complex inputs and examples that it would really help to understand, and it would help us to simplify the problem or understand it better by asking these sort of questions. These examples are really just another form of understanding the problem better before we tackle it. So it ties into the previous video a lot, understanding the question. Next up, explore examples with empty inputs. So what if, somebody does char count and doesn't pass anything in, like this, or an empty string? What do we want to return? Do we want to return an empty object at the end? Do we want to return null or false or undefined, or maybe an error? And that's tied to exploring examples with invalid inputs. So what if somebody passes in something that isn't a string? They pass in a number, or they pass in an object, or they pass in null. There's all sorts of these edge cases. And understanding these edge cases in an interview setting, often it's not that important usually, but it can be really important in the real world to help you build a more robust solution, something that is more foolproof. So it's still important to keep that in mind. And sometimes it can give you a bit of insight into how the problem works or how you should solve it. Welcome back. So let's move on to part 3, step 3 of solving a problem, or at least trying to. So we understand the problem, we explored concrete examples. Now, before we start typing code, I like to break it down. And I actually like to do, it sounds like, I don't start dancing in the middle of the interview. By break it down, I mean take the actual steps of the problem and write them down. It doesn't have to be full pseudocode. It doesn't have to be valid, syntax. I like to do just little comments as a guide for the steps I need to take. And especially in an interview setting, this is really important. What a lot of interviewers are looking for is, you to communicate what you're doing. You don't want to just start typing right away or start writing code on a whiteboard silently with your brow furrowed, angrily writing code. It's much better to say, all right, here's the steps I'm going to try and take. Sometimes you can get a little hint too. You can throw in, do you think that'll work? Or, does that sound crazy to you? Or could this be the right way of doing it? And sometimes they'll give you a little hint. So breaking it down can be really important. So I recommend explicitly writing out the steps that you need to take. It doesn't have to be a ton of detail. It doesn't have to be line by line, every line you need to write. Just the basic components of the solution. So this forces you to think about your code before you actually write it, so that you're not just freewheeling and trying to come up with it on the fly. And it also helps you kind of catch or figure out any lingering questions or, parts that you're scared of or that you don't understand. So that's why I really recommend doing this. It helps you just lay out your steps, and that's always nice, and it helps you stay focused, but also it helps you highlight the problems you might still not be confident about. And then you can just dive in and start writing the code. So let me show you what it looks like if I were to break down this same problem. Write a function which takes in a string and returns counts of each character in the string. So the same problem from before. All right, so I have a sheet of paper or a whiteboard or whatever it is in my interview. I've written down some examples, and now I'm going to type up the skeleton of my function. So we'll call it char count, and we know that it accepts a string. It's called str. And then I'm going to stop with the actual code, and I'm going to start writing some comments. I'm going to break it down for myself. And the simplest thing we could start with is just do something, and then add in our return value. Return an object with keys that are lowercase alphanumeric characters in the string. So just to clarify, I've decided, or my interviewer decided, that we only need to care about alphanumeric characters, lowercase as well. So that means, in this example, your PIN number is 1234. We are keeping track of the numbers, and we are keeping track of all letters, but only lowercasing them. So PIN, PIN, we're going to keep that, a 1 lowercase p, 2 lowercase i's. This one here, and this one here. Okay, so we could start with something simple like this, put our return value down there. I'm going to duplicate this and expand upon it. So if we think about the actual steps of what we want to do, well, we're going to need to do something once for every character in the string, right? We're going to need to go over it. At some point, we also need to make an object that we're going to return at the very end, right? That one's simple. We need to make the thing that we're going to return. We need to return it at the end. But the bulk of the logic involves looping over every character in our string and doing something. So I might start, let's get rid of this and simplify this a bit. I would start with something like make object to return at end. Then after that, I would do, loop over string, and we'll come back and fill in the detail. And then return object at end. So now we have the very basic steps, and we can fill in the blanks, but looping over string is definitely the bulk of our logic. So what do we need to do? Well, if we loop over the string, we know that we're going to need to look at each character, and let's start with y. We're going to need to look at y and lowercase it. So we could lowercase the entire string at the beginning. That's one option. Or we could lowercase each character as we go. But we're going to start by taking a look at this character, and what do? We check, well, are there any in our object already? And technically it's going to start out empty, so there's nothing in there. So then we would add y in and set its count to 1. But if there already was a y in that object, then we would add 1 to it. So that's really the logic. We're going to loop over string for each character. Then we'll do something like if I'll just do char is in our object. Let's say is a key in object, add 1 to count. If the character is not in our object, add it and set value to 1. So that makes sense. Although this isn't accounting for the fact that we only care about alphanumeric characters. So the spaces we're not going to add in. The exclamation point we won't add in. So we should clarify that. We should say if the character is a number / letter and is a key in our object, add 1 to count. If the character is a number / letter and not in our object, add it to the object and set value to 1. And then otherwise, we'll say like if character is something else, a space, a period, etc., don't do anything. And then at the very end, we return our object. So we make our object at the beginning, then we go character by character. We have our main logic. It will just be a loop, probably a for loop. And then we'll take each character, look at it, make sure, check, is it alphanumeric? Is it a number or a letter? If it is, then we will add it into our object. And that means either incrementing an existing part of our object or adding it to the object and setting its value to 1. And if it's not alphanumeric, we just don't do anything. So we build up our object one character at a time, and then we return it at the very end. And now that we have these basic steps, we can now go fill in the blanks. And I highly recommend, this is a simpler problem. Some of you probably a lot of you probably could solve this without having to do any of this, pseudocode. And this isn't even full pseudocode, but just writing these comments out. But for more complicated problems, it really can be a lifesaver. Because if you write out the steps, especially in an interview, you write out the steps, you know what you need to do, even if you're not sure how to accomplish it. It demonstrates to your interviewer that you at least have formulated an approach. And if you run out of time and you only get halfway there, but you have the layout for what you would have done. So like if we stopped here, for example, this is a short problem, but let's say this is where we ran out of time. Everything is implemented in code. If we have these notes down here, our interviewer could see that we knew where we were going, or we had a general idea. And that can often make the difference in demonstrating that you are competent, even if you don't finish the problem. I've seen many people get jobs who didn't, they thought that they failed the interview because they didn't finish the problem. They didn't have the right return value at the end. But often these problems are made to be so difficult or so time consuming that you're not supposed to finish. And it's really about seeing your process. So that's what all this is about, the process. Welcome back. So we've talked about the first 3 components, the first 3 steps in this 5-step problem-solving approach. Understand the problem, then go through some concrete examples. Talk about edge cases, inputs, outputs, that sort of thing. Next, break down your approach, your solution into a couple of steps that you can follow. It doesn't have to be insanely detailed, but it does help if you can come up with pretty thorough steps. And then sometimes, if all of that went well and you feel good about it, you can just solve. and you write your code right away. And I should note that's not the last step. Even if you do solve it, there's still a step after this. But sometimes you're not ready to solve the entire problem at this point. You might feel good about 80%, but then there's this one thing you're not sure how to do. Or there's, two things that are really challenging. So that's where simplify comes in. Solve or simplify, or solve/simplify. Okay, designated slide. So solve the problem if you can, and if you can't, solve a simpler problem. Now that doesn't mean changing the subject entirely and picking, let's solve 1 + 1. That's stupid. I don't know why I said that. What it really means is trying to ignore the part that is giving you a really hard time in order to focus on everything else. So why is it even worth doing this? Well, first of all, in an interview setting, often you want to have something to show for yourself. So instead of getting stuck on one difficult part of a problem and making zero progress at all because you're putting all of your eggs in one basket of being able to solve it 100% before you even start writing code, that often can look bad. It's much better, even if you know there's some part that you're going to get stuck on, it's much better to just start writing code to do the stuff you know how to do, all the while keeping in mind that you do need to incorporate that harder part back in. Secondly, it's pretty common that in simplifying a problem, you'll gain insight into the actual solution, into the harder part of the problem, and something will click into place. So I really, really recommend that if you do get stuck on something, but you know where to start, or you know a place to start, you should just go for it. Once, of course, you've done the first 3 steps. You've understood the problem, you've done concrete examples, and you've broken it down into steps. So as far as the simplification, I like to think about it this way. So you find the core difficulty in what you're trying to do, the thing that is tripping you up, that you're panicking about. Temporarily ignore that difficulty, write a simplified solution, and then incorporate that difficulty back in if you can. And along the way, often at this step, you'll gain insight into how this part works. So one more time, let's return to this example. Write a function which takes in a string and returns counts of each character in the string. All right, so char count, remember, should return an object that contains all the a count for every alphanumeric character in an input string. So ignoring every non-letter or number, and all the letters should be lowercased. So there's a couple things that could present difficulties here. To start off with the really simple, obvious ones, if someone has trouble with looping, then this could be problematic. And if you did have trouble with looping, then I would, if it were me and I struggled with looping, I would start by creating an object and just working with the first character in that string, or hard coding in the first 5 characters. Probably, not going to get me a job, but at least it's a start. And then once you figure out, how to handle it for one character, the very first item in a string, like right here, you lowercase it, or you add it to the object, or you check if it's in the object, and then you do it for the second character, then the third character, then you find a pattern that you can turn into a loop. Another thing that could be problematic is someone might not be comfortable working with keys and values in objects. Again, a very simple problem, and you're probably not going to be interviewing for a job if you have trouble doing that. But if you were trying to solve a problem anyway, maybe you're at home and you don't feel good about using keys and values and manipulating objects, you could start with a loop and loop over every character in the string and maybe just print out that character. Or probably a more realistic thing is that you may not be comfortable working with uppercase and lowercase strings. Or if you're in an interview setting, you might not remember. Sometimes, you don't have access to a computer if you're on a whiteboard. You might not remember the exact method that lowercases or uppercases a string in JavaScript. So I would just ignore that. I would just start with the main logic and then, put uppercase and lowercase characters in there and just deal with it later. And just say out loud, like, I can't remember exactly how to do this, so I'm just going to skip that part. And then at the end, I'll go back. Or if I had my computer, I would just quickly Google how to lowercase something in JavaScript, and I'd lowercase everything at the beginning. Something like that. Now, if I did actually face this in an interview, which, to be fair, it's a pretty easy problem, at least on the surface, the thing that would probably trip me up the most and trip up most students that I've worked with is making sure a character is alphanumeric. Making this object to return at the end, simple enough. We could just call it like frequency or count result maybe. It's an empty object. Loop over the string for each character. So I'll just do for var I equals 0. I is less than string.length. All right, then this gives me each character, and we can start off by just adding each character into that object or checking if it's in that object. So ignore the number letter part, ignore alphanumeric, ignore the casing even, and just check if that exact character is in the object. So I would just do something like if result of, let's make a variable here to make this a little more legible. So let's make a variable called char equals string of I, instead of having to put string of I all over the place. So if result of char is greater than 0, meaning it's already in there, then I'm going to just copy this and do plus plus. Else, we're going to set result of char equal to 1, because that means it's not in there yet. And this is basically where I would start, assuming I don't have a typo. So if we put my pseudocode, let's move this here. If the character, we haven't conquered this number letter problem, but we're at least getting 90% of the way there. Just put my little bits of pseudocode here. And we're not tackling this. Return the object at the end. So then return result. And let's see if it works. Okay, I ran my solution. And if I run char count, is this large enough? Char count of hello. Let's make this a bit larger. It works. You can see that we get H1, E1, L2, O1. If I instead do hi there, like this, you can see we're also getting uppercase H. We're getting, what else? Exclamation point. We're getting space. So that's not ideal, but we're really close. So now, if we have this done, we could at least figure out the lowercase part, or, maybe our interviewer gives us a hint, or we have access to figure out how to do the lowercase. It's just a method to lowercase, or we could uppercase everything. But it's a matter of if we want to lowercase the entire string first, or we could do it, one character at a time. So we could come in here and just do 2 lowercase like that, rerun our code, and now if we look at char count of hi there, it all works. We have 2 H, E is 2, casing doesn't matter. Now we still have the non-alphanumeric characters, but this gets us most of the way there. And now we could do some additional research. We could ask our interviewer if they had suggestions. We could just start spitballing on how to do that alphanumeric component. So to tell if a number or if a character is alphanumeric, there's a couple options. We could define, an array essentially containing every valid character, which would be really annoying. So we could have an array that was massive, that had A, B, C, D, uppercase and lowercase, and every alphanumeric character, which I guess is not that many, but still, it would be a long array. We could use a regular expression, which is probably what I would do, and I'll show you a solution with that in the next video. You could also probably do something with the character codes, the ASCII codes. There's a lot of different ways you could do it. And all that we would need to do is plug it in to our existing code. So if we were checking if it was a valid character, I would maybe just add an additional if statement and nest these inside of that if statement. So all of this logic stays. We wouldn't be deleting anything. We're just adding in that one little component. So to wrap this up, this isn't a particularly challenging question, in all honesty, but there's still a lot of different approaches that we could take, a lot of different ways of solving it. And like I said, the next solution I'll show you in the next video, as well as a couple refactored versions, vary quite a bit. But at the end of the day, we write what we can, right? We loop, we add things into the object, we have a couple conditionals. Even if it's not perfect, we're still 90-something% of the way there. We just need a way to check if something is alphanumeric. And in an interview, if you can get 90% of the way there, and you just have this one little thing that you need to complete, you tell the interviewer, there's 3 different ways, I'm not sure which one's best, or I'm not sure how to do this. Do you have any suggestions on what I could do to check if something is alphanumeric? That sort of line of questioning, if you get 90% of the way there, it demonstrates a lot about your problem-solving ability, rather than just fixating on that before you even begin. So it's much better to write something, not just like rashly put stuff on the page and hope it works, but get the right pieces in place so that once you figure out the hard part, you can just plug it in. All right, welcome back. We've made it to the final step out of 5, and this is probably the most important step when it comes to improving, becoming a better developer. So we've understood the problem, we've talked about concrete examples, broke it down into steps, we solved it or simplified it to help us solve it, and then once we have something, whether it's an amazing solution or super scrappy, it's time to look back and refactor. I know it's tempting that once you have something workable, something good enough that does what it needs to do, it's tempting to just, shut your laptop or close the book and go, play video games or do something else. It's really tempting because often you can get by with something that just works. And in a lot of jobs and a lot of scenarios, all that matters is that something works. It doesn't have to be beautiful. It doesn't have to be the most efficient code on earth. But it's really, really important to strive for those goals. Obviously, if you're a one-man team or one-woman team and you're creating, company on your own and you have a deadline of tomorrow and you have to just write code that works, then yeah, it's fine to be scrappy. But it's really important to try and improve your code. And it's a missed opportunity if you don't take the time to look at your code, look back and reflect on it. And I don't just mean, longingly in a poetic way. I mean, look at the individual components line by line. Talk about the parts you don't like, or what do you not like about how the code itself looks, how it reads, how easy it is to understand. Obviously, what most people care about is efficiency when they're looking at code, but there's often a balance that needs to be struck too between those two polars of efficiency and legibility. And in an interview setting, it's really important to ask these questions often out loud. You have a finished solution. You can be proud of that. Something works. I like to then take a moment and sort of go line by line and think, this is not ideal. I think maybe there's a better way of doing this, but I'm not confident. I would Google if there was a faster way of doing this, that sort of thing. So I'm going to go through that. But here's sort of a checklist of questions you could ask yourself. Can you check the result? So that one's obvious. We need to make sure our code works. Can you derive the result differently? So this is referring to the fact that there's rarely one solution and only one solution to a problem. So can you think about different approaches? Now that you've solved it one way, is there another way that seems viable that you couldn't think of earlier? Can you see it at a glance or understand it at a glance? So how intuitive is your solution? Does it make sense when you look at it on paper, on a whiteboard, in your code editor? Can you use the result or method for some other problem? One of the great benefits of solving a problem is that it helps you sort of develop a spider sense, an intuition for solving other problems. So whenever you write down a solution, it's worth pausing and asking yourself if there's any similarities between this solution or this problem and others you've encountered in the past. So maybe not in an interview setting necessarily, but this has happened to me a couple times. I solve some problem and it sort of unlocks the solution to another problem on a different project or a different company or something like that. So it's something to keep in mind. Okay, next up, can you improve the performance of your solution? So this is one that, like I said, is probably at the top of a lot of people's minds when they write a solution. So how can we make it perform better? Mainly, time complexity and space complexity. And that's something we talk a lot about in this course. So if you're not super comfortable measuring that or calculating it, that's okay. But we can still identify certain things that might be poorly performing or slow. For example, like a bunch of loops that are nested. Try and avoid that. Can you think of any other ways to refactor your code? If you're working for a company, does your code follow company guidelines, a style guide? Does it follow conventions of the language? Is the spacing consistent? Just minor things, but this is important to show, even in an interview setting, at least acknowledge the fact that your code isn't neat and that you would prefer to make it neater if you didn't have time. And lastly, how have other people solved this problem? So in an interview setting, often, the interviewers ask the same question to many different candidates. Some companies I've seen have used the same question for like years. And so they've probably seen a lot of candidates and a lot of solutions. So in an interview, it can be really beneficial after you have something, whether it works or doesn't work, at the end to pick their brain. Say, what other approaches are there? What did I miss? How have you seen people solve this? And sometimes people like to share the most effective or simplest solution. Other times, people like to talk about the craziest, most eccentric solution, the most unexpected way of solving it, even if it's not the most efficient. But you can learn a lot from looking at how other people have solved the same problem. Now, if you're on your own, you're working on a project, an application, and you're solving a problem, often you're solving something that other people haven't solved before. Otherwise, you may not be prioritizing solving it yourself, right? If you need to, you're not going to build your own database from scratch. You can use someone else's database. But sometimes there are certain things that you do implement on your own, and it's worth looking at other implementations, whether it's in a different language. This happens pretty frequently to me. If I'm writing something, you may not find it in JavaScript. You can search around and you might find someone else's code in Java or in Python. And you can take that and compare it to yours, depending on how comfortable you are doing that. And it can be really useful, and you can find ideas and different approaches. Anyway, so these are a lot of questions here that you can ask yourself. But my point is that refactoring is really important. And it doesn't even have to be refactoring, which is why I called it look back and refactor. Because sometimes you could be happy with your code, or you might not want to make changes, but it's worth thinking about it. It's worth analyzing your code and reflecting on it, looking back on it, rather than simply writing something that works and calling it a day. So let's go through a simplified version of that process with my solution here. So I changed my solution a bit. Here it is, by the way. Everything's the same as what we saw in the last video. I added in a simple regular expression to test if a character is alphanumeric. So if it's a lowercase a through z or a 0 through 9. And this is how I'm weeding out all the non-alphanumeric characters, spaces, underscores, dashes, periods, commas, and only doing the letters and numbers. And I lowercase it first, and then I test each character. So if we make it to this point, it's the character is either a number or a letter. And then we just check, like we did in the last video. If the character is already in that object, meaning it's greater than 0, it's set to 1 or 2 or 3, for example, just add 1 to the value. Otherwise, initialize it to 1. I'm not sure where that extra 1 came from. And then we return the object at the end. So this works. And if I finish this at the end of an interview, this was my solution. The main pain points, the things that I would point out, there's a couple. One easy fix is I'm not really a fan of using a for loop. Obviously, for loops are great and they've been around forever. But in today's landscape, I would probably use a for of loop just to simplify this so we don't have to work with I. Because if we do for of on a string, it gives us each character immediately. There's no reason to go, this is an extra step. Loop through a range of numbers, then take that number to get an individual character when I could replace it. So I'll refactor this, just keep this here, but slowly refactor it down here. And this isn't really a performance thing. It's just aesthetics, I guess. So for, I'd say var char of that string. Then we don't need to define char again. We're going to lowercase it. So let's do this. Char.toLowercase. So we no longer have to do string of I. We're just working with char. And this should work still. Let's just verify that. So I paste it in. Let's do it on hello, hi, and throw in some punctuation. And it looks like it's working. We have 2 H's, lowercased. Okay, that's all good. Now a small syntax change that we could make. This isn't a huge deal, but this kind of bothers me when I look at it. It takes up a lot of space to do a very simple thing. We're either adding 1 to a number or setting a number to 1 or initializing a value in a key. Oh my gosh, in an object, or initializing the value to 0. So we're initializing it to 0 or adding 1 to it, which is a pretty simple thing. And it's a simple if else. So often I look to combine these into a single line if possible. And it can be difficult if you're in a stressful interview situation. Often I just write this first thing that comes to mind, the simplest, most basic syntax, and then come back and clean it up. So we can replace this here with this line. So what this does is it takes a character like A, accesses the corresponding value in our object. So if it's truthy, we're going to add 1 to it, meaning if there's a value in there already. If there's nothing in there, we're going to set it to 1. So we basically have 2 scenarios. Object char equals this, object char plus 1, or if it's falsy, set it equal to 1. So this is a nice way of cleaning up our code, shortening it quite a bit. And just to verify that it still works, one more time, paste it in correctly, and it looks like it's working. So the last thing, and this is probably the most important thing that I would think about here, we did a couple stylistic changes. We could use some more ES 2015 syntax. replace var with let and const, and that's probably a good idea to do. But the most pressing thing in my mind that I'm unsure about, if this was in an interview setting, I would say, okay, well, I'm using a regular expression here because I know how to do that, and it's a quick way, a relatively short way of checking for a certain pattern, in our case to see if a character is alphanumeric, a letter or a number. But I'm not sure how efficient it actually is. And I would say that. I'd say, I've heard certain things that in JavaScript, and this is true, in JavaScript, regular expressions, the performance can vary depending on what you're doing and depending on the browser that you're in. In particular, Chrome had some issues with regular expressions a while back. So I don't try and avoid them because they can be very useful. But for something like this is a very simple usage of a regular expression. Often people will use them to find patterns like credit card patterns or phone numbers or addresses or much more complicated things like matching a URL pattern, which would be a huge pain otherwise. But just checking if something is a letter or a number, I think there could be a better way to do this. So I would say that out loud, and this might not come to mind right away. It didn't come to my mind right away either. But what you can do, and I just did some research to figure this out, is use char at or character at. So if we, take a string like hi, and then do char code at rather than char code at, and give it an index, it gives us a number, 104, which is the character code for h, for lowercase h. If we did, let's just do I, it's 105. Hij comes next in the alphabet, it's 106. So these are in a range of numbers. And so what we could do is replace our regular expression with using a simple mathematical comparison. So we would do a character or char code at, and give it, let's just say always 0 for now. And then we would check if it's a valid character code. And I found someone doing this online, which is what sort of inspired me to look at this. This person wrote a little bit of a performance test where they're testing if something is alphanumeric down here using a regular expression, and here they're testing if something is alphanumeric using a character code. So you can see between 47 and 58 are the numeric character codes. Between 64 and 91 are uppercase alphas, I guess, the alphabet. And lowercase letters are 96 to 123. So we can just quickly, a couple Boolean comparisons, which are very, very easy and fast to do in any programming language. They're pretty much one of the simplest, if the simplest operation you could do, are these simple Boolean comparisons. And this person demonstrates actually that if you repeat this over and over and over again, you can see that the non-regular expression version is indeed faster. 55% slower using regular expressions. So I'm showing this to you not to say, I would have come up with this in an interview, because I probably wouldn't have. I might have considered it, but I certainly wouldn't know the character codes. I would have just gone with what I felt most comfortable doing. But then I would, at the very end, add a little note in to my interviewer saying, hey, maybe there's a better way. I would Google it. I have a feeling regular expressions might not be the fastest way. So what I did is actually turn this into a function called isAlphanumeric, but it works in a single character. So you pass in a character one at a time, and then we get the character code at index 0 because it's a one character string. Technically, you can actually leave this blank and it still works, but I like to be explicit, so I'll put the 0 in there. It gives us the first character, which is the only character. So if we're passing in hello like this, I would call isAlphanumeric on H, call it on E, on L, and it should return true every time. And then if we have a space or an exclamation point, it will return false. So I've created this function. Now what I'm going to do is get rid of this regular expression and refactor it to be if is alphanumeric of character, just like that. Another thing to consider is the placement of when we do the lowercasing. Is it better to lowercase everything at the beginning, the entire string, and then check each character to see if it's alphanumeric? Is it better to first check for alphanumeric characters so that we weed out all the spaces, the punctuation, everything that's not valid, and then lowercase afterwards? And I'm actually not positive on how I feel about it. I've gone back and forth. It depends on what your strings look like, what the inputs look like. If they are generally all alphanumeric versus if you have really weird strings that have a ton of random characters that aren't alphanumeric, I think that the answer would depend on that. But what I'm going to do is just run it like this. So if is alphanumeric, then we'll lowercase it and then add it into our object. So I like this solution. One, I like having this separate function so that this is pretty readable in my opinion, like for each character of our string. Like that's very nice and legible. For a character in the string, if that character is alphanumeric, we're going to lowercase it and then add it into our object or initialize it to 1 or add 1 to the current value. So I like this solution. I think it's clean and readable, but also allegedly, at least according to some stuff we found online, is more efficient to use character codes compared to a regular expression like we had up here. So I know this is getting a bit long, but I just wanted to show you my process. This is the solution I wrote first, and then I've kind of just thought about it more and did some more research. And this is the solution I prefer, not just stylistically, not just because it's shorter. It's actually not shorter because of this code here. Of course, you could put all of this code right in here and not have a separate function, but I think it reads so much better like this. All right, so let's make sure it works. Char count of, sure, this one again. Hello world, hi. So there should be 2 H's. There's 1 E, what else? 3 L's, and we're ignoring case, and also we're ignoring non-alphanumeric characters. All right, so that was a lot there. Hopefully you agree. Maybe you don't. I have some feedback on my refactor. But just in asking myself those questions about how did other people do this? How could I improve this? Where are the stylistic changes I could make? Our solution looks vastly different than it did before. Not that there's anything wrong with this one out of the box. Okay. All right, welcome back. This will be a 30-second video. I just wanted to summarize the steps. So to recap, sort of the 5-step protocol here, whether you're faced with a tough interview challenge and you're at a whiteboard and there's a bunch of people watching you, or you're trying to solve something on your own for a novel, challenge you faced, an app you're trying to build, trying to figure out how to sort search results, whatever it is, these are the steps that I like to go through. Make sure you understand the problem. And a lot of this, the way I taught it or talked about it was geared towards interviews, like I said, especially things like understanding the problem. So ask questions of your interviewer, of course. Clarify the problem. Make sure you understand it. But even if it's just you working on something, make sure you understand it too. Make sure that you really have thought out how your solution, how your application it should operate, how it should behave in every scenario. And that goes hand in hand with exploring concrete examples. These two are really both about understanding the problem, understanding the inputs, understanding the outputs, understanding edge cases. How do you handle errors? What happens when a user enters something invalid? All these different things all have to do with just sort of understanding from the outset how everything should work. Onset, outset, I don't know. Break it down. So at this point, if you like to write like totally perfect pseudocode line by line, you can do that. Or just break out a couple steps to lay out a game plan for the code you need to implement. This is really helpful, especially in an interview if you're timed and you know that you're going to run out of time. It can be useful to write your game plan out so you can show them, hey, this is where I was going. Even though I only actually implemented 40% of this, here's the other steps that I was going to do. So make sure you know where you're going before you just start typing code. Often that's a bad way. You can end up in a hole. You can confuse yourself. It's happened to me many times in interviews. If you just start, you think you know where to start and you'll figure out the rest as you go. Often you pigeonhole yourself into one approach, and then I start to panic because it's not working out. And I take a step back and usually erase everything I've done and start over and plan it out. So then solve, and if you can't solve the problem right away, solve a problem that you can, even if it's simpler. If you simplify, you remove some core difficulty, core challenge, try and solve something where you can then reincorporate that core difficulty back in. So we talked about in 2 videos ago, if you're not sure how to test for something being alphanumeric, ignore that part and just write the problem, write the solution, ignoring the alphanumeric part so that you could then plug it in later. And then finally, what I said was the most important for learning or improving as a developer, looking back on your code and sometimes refactoring it. Sometimes just looking back and analyzing it and patting yourself on the back. Most of the time, there's room to refactor. Even if you're a totally expert developer, it can be very useful to look at other people's solutions or to scrutinize your own and figure out what you could have done better. All right, so those are the steps I recommend if you're ever faced with a tough challenge, especially if you're in an interview. I would absolutely recommend always starting off with understanding the problem, exploring examples. Like 1 and 2, for sure, do that out loud. Make sure the interviewer hears you, bring them into the process, tell them what you're doing. Breaking it down, write the steps down, talk out loud. Solve it, of course, if you can, and then look back on your code and refactor if you can. All of these, honestly, they're equally important in an interview setting as well as in real life. But I think most of you care about interviews for the most part, so I'm gearing it towards that. Okay, so that's the wishy-washy part of problem solving, sort of the approach, the steps that you can take mentally to prepare yourself. Next, we're going to talk about some patterns for code. There are a couple of archetypes, blueprints for solutions that may come in handy. I honestly think this stuff is much more useful in the real world because it applies to all sorts of problems. What we're going to learn next is a little more specific, but for the types of problems it helps with, it really helps. Okay, that's up next.